Hello colleagues, this lesson is dedicated to the next solid principle, I, interface segregation principle. We'll talk more about the principle, we'll learn why do we need to follow it, and on real code examples I will demo how to apply the principle. As usual, let's start from the principle definition. The interface segregation principle states that clients should not be forced to depend on methods that they don't use. Being software engineers, we should focus on creation of thin interfaces instead of creation fat interfaces. Instead of declaring interface which can solve all problems and set the contract for the most of business logic in your program, you should create small and specific interfaces. Probably impact of fat interfaces is not obvious right now. Let me explain what potentially can go wrong if you will force your clients to implement methods they don't need. By creating fat interfaces, we bring complexity to our program, and we can't guarantee that expected behavior will be supported in all successors. It is easier to implement multiple small interfaces rather than give implementation to the behavior that you don't need. Small interfaces easy to maintain, support, and scale. But in the meantime, you should avoid of creating interface for one method every time, because this approach will lead you to having dozens of small interfaces with one single method. Each interface should have clearly defined behavior. In perfect case, your interface should be cohesive. That means interface should contain group of operations that logically connected. We also need to keep our code in line with Liskov substitution principle. Enough talks, let's code. Now I'm going to share with you code examples so that you could understand how we can apply interface segregation principle in real life. Let's start from the problem statement. Imagine that we develop video game, for example, GTA San Andreas, and we need to declare some type to represent all vehicles. I have vehicle interface which sets contracts for different behavior, drive, fly, and sail. Now I can have concrete types, car, plane, and boat. All of them are vehicles, so logically everything is correct. But car doesn't need fly and sail method. Plane doesn't need sail method. Boat doesn't need drive and fly method. So you see that clients of our type vehicle must give implementation to methods which they don't need. How I have to implement fly method for boat? But by the time you understand this, a lot of other classes already use vehicle type as a main abstraction to interact with this group of objects. This is a violation of interface segregation principle. What is the recommended way to fix this? Let's have 3 thin interfaces. For example, drivable, sailable, flyable. And I will separate behavior between these types. Car and motorcycle will implement drivable interface, because both of these types should have drive method. In this case, each concrete type will implement only that interface which it actually needed. And now, clients of our interfaces are not forced to implement methods they don't need. The good thing is that in Java it is allowed to implement multiple interfaces. For example, each plane can drive and fly. Let me implement drivable and flyable interface in plane class. Or imagine that now we want to implement Vortex from GTA San Andreas. For those who don't remember what Vortex is from San Andreas, I will remind. Vortex is a vehicle that can drive and sail from the video game GTA. So here is the Vortex that implements drivable and sailable interface. And I can give implementation to this behavior. Now, when I follow interface segregation principle, I have multiple small interfaces, and my chances to catch runtime exception are lower. Moreover, now I have more flexibility in scaling of my application and other entities. Let's recap what we have learned today. Today we learned what interface segregation principle is, we discussed why we need to follow it and what negative consequences may appear in case we ignore this principle. On real code examples, we learned how to apply the principle for specific type hierarchy. That's it for this lesson. Thanks a lot for your attention. See you in the next lesson.